Alright, so I pulled this from your textbook to go over mutually exclusive events as well as the addition rule. So it says if event A and B are mutually exclusive, then probability of A or B happening is just the probability of A plus the probability of B. By the way, mutually exclusive means that pretty much those two events cannot happen at the same time. Like right now. Are you sitting or are you standing? Now you have to be one or the other, because if you're sitting, you're not standing. But if you're standing, well then you're not sitting. You have to choose. So mutually exclusive is like you got to choose either or. Can't have both. I know, it's sad. And in math, we are reminded of its sadness because, mutually exclusive means the two events can't occur at the same time. That means the probability of A or B happening is just, probability of A plus the probability of B. Now, in the case that events are not mutually exclusive, like for example, I could pull a red card from a deck of 52 cards. And if I pulled a red card, it could also be an even card, like 2, 4, 6, 8, 10, and still be red. So that means we could have two events happen at the same time. In that case, if we wanted to find the probability of A or B, we'd have to take our probability of A plus the probability of B, take away when it's both. Okay. So with that being said, we're going to use some tables. We're going to try and figure out how do I figure out probability with tables for 19.4 is explain. Alright, so in our explain section, they give us use a two-way table to determine the probabilities of either senior or a girl. So let's determine the either senior or a girl by first looking up what is the probability of just a senior, the probability of just a girl, and of course that we have seniors who are also, if I could spell, girls. Alright, so first things first, let's look at our table. So again, I'm going to kind of fill in these. So senior, girl, and senior, and girl. Alright, so just so you know, your total, as I'm going to highlight this for you, for all of these is going to be 808. Just in case you're wondering, you're like, why is that? Well, it's kind of right there, it's kind of the total. Alright, let's go ahead and fill in the rest. So I'm going to write 808. And yes, we are going to reduce, just so you know. So total number of seniors. Well, I see the total number of seniors is 202. Total number of girls in the whole school is 412. Yes, we are going to reduce. It's going to happen, guys. All right. Now, 808. Sorry, I almost forgot about that 808. Now let's see how many are actually girls and seniors. So I'm going to use another highlighting tool so you can see that. So I'm going to highlight across for girls. And highlight down for seniors. And I see the number that they cross at is actually 108. So I'm going to write 108. Probably put it in a pen so you can see that. So that should be 108. And now what we're going to use is we're going to use our Desmos calculator to kind of reduce all these fractions for us. So that way we can determine the probability of a senior or a girl by taking some of the values we found, which was the probability of a senior, plus the probability of a girl, taking away the probability of a senior and a girl. Okay, but first we got to reduce these fractions, so let's do that first. So we'll go ahead and reduce using our Desmos calculator the first fraction of 202 divided by 808, and that'd be about 1/4. We'll also do 412, which is our second fraction, divided by 808. And, oh, I want to change that into a fraction, 103 over 202. And last but not least, 108 divided by 808. Let's put that as a fraction. That's going to be 27 over 202. So, and let's go ahead and record that here. So let's record those here. That would be 1 over 4, 103 over 202, and then of course 27 over 202. So for your seniors, that would be 1/4, 103, 202, and then of course 27 over 202. And actually, since we have the calculator available to us, we can actually compute that on the Desmos calculator, which we'll do right now. Alright, so that would be 1 over 4 plus 103 over 202 plus 27 over 202. And that would come out to about 361. Oh, sorry. That's supposed to be a minus, isn't it? Yes, it is. And as you can see, that would be 253 over 404. So let's go ahead and record that on our piece of paper right here. So that would be 253 over 404. Let's do explain B, or the part B. So here, let's say I have, find the probability using a two-way table, domestic versus late. So there's domestic versus international flights, and late or on time. So let's figure out what our domestic flights would be. Again, our total in this case would be 180. So I'm going to write that in for all. As you can see here, for domestic flights, the total is 120. For late flights, that would be 18. All right. And then last but not least, domestic and late. So that would be where they kind of cross, which I believe this would be domestic and late. So let's go ahead and reduce all of these. Once we reduce that, we'll go ahead and put these here and figure out, okay, what is our probability going to be? Oh, and notice that we have an extra step because there's like the tiniest little complement right here. You know, that means not domestic and not late. So there's going to be one more step to figure out what the not would be. So that's why we had to figure out what the probability of domestic or late would. Domestic or late first. So that way we can subtract from 1. So this is taking a little bit from previous sections, so they might do that from time to time. Just keep that in mind. So let's go ahead and reduce these fractions. 120 divided by 180, and that's going to be 2/3. And then of course 18 divided by 180, and that would be 1/10. And then last but not least, 12 divided by 180, and that would be 1/15. Since we are going to use these values to add and then subtract, we might as well do that now. So that would be 2/3 plus 1/10 minus 1/15. And that would be about 7/10. Alright, so let's go ahead and record these answers here on our worksheet. That would be 2/3, 1/10, 1/15. So that was 2/3, 1/10 minus 1/15, which we got that to be 7/10. So that would be 1, take away our domestic and late, so we can figure out how many are not domestic and late. And just to make a whole, back to a whole, I need 10 parts to make back a whole. 7 plus what gets you 10? 3. Even without using a calculator, we were able to work that out. Just like it says here, stop here and do the problems in the packet right now.